Okay, in the following examples, we are asked to transform the equation or the function in this case of the parabola from standard to vertex form. So this is standard form. So it's ax squared plus bx plus c. This is standard form. We're going to go into vertex form. Now in order to do that, what we're going to do is we are going to recall how to complete the square. So if you don't quite remember how to complete the square right now, I'll put a link in the description at the bottom so that you can see how to complete the square. All right, but we're going to assume that you know how to do that at this point. All right, so what I'm going to do is I'm going to take this x squared minus 6x plus 7, and I just like to set it equal to 0 because it's just easier for me to work with it when I'm trying to complete the square. So I'm going to set it equal to 0, and then I'm going to say, okay, well then x squared minus 6x, and then I'm going to put plus parentheses square equals, and then it's negative 7 plus parentheses square. So notice what I did. I moved the 7 to the other side of the equal sign. All right, now what goes in here is the completing the square part. So it's actually half of the b coefficient. So half of negative 6, which is negative 3. And what you do to one side, you do to the other. So now we're ready to do the completing of the square. So right here, we're going to pull this together, and this is essentially the trick of the other video. You pull this in, x minus 3, quantity square, because this actually follows that this right here is a binomial square, a perfect square, a trinomial, which is this right here. So let's see here. Now on this side, we know this is 9, so negative 7 plus 9 is 2. And now what we're ready to do is move this back to the other side. So remember, we kind of created this equal sign out of nowhere. Now we're going to compensate by moving the 2 back to the other side and just make that equal sign disappear. Okay, so I'm going to rewrite my function f of x to say that f of x equals x minus 3 quantity square minus 2. So let's talk about this for a second. If you do the binomial squared here, and then you subtract 2, so you're going to get x squared minus 6x plus 9, and then subtract 2, you end up exactly with this right here. So we have now completed the square for this, and now that we've completed the square, we have our function, which was in standard form, now in vertex form. So remember, the vertex is simply the h and the k here. All right, so the h right here is the negative 3. Well, it's not negative 3 so much as it's the opposite, so it's positive 3, but I'll write an h here, and I'll write a k here. So remember, whenever it's inside the parentheses, it's always the opposite. But whenever you have it outside like this k, it's always direct. So we can say then that the vertex, all right, and recall that the vertex is h comma k. The vertex here is positive 3 and negative 2. So again, this is your h and this is your k. All right, so I think it's probably helpful to look at one more example. So we're going to go ahead and do that. And again, we're going to follow the same process that we did in the previous example. So I'm going to say, okay, x squared plus 2x minus 5 equals 0. All right, and I'm going to say x squared plus 2x plus parentheses square equals a positive 5, because this moves to the other side and it changes its sign. And then plus parentheses squared. What you do to one side, you do to the other. And what goes in here, you might ask? Well, it's, remember, half of the b coefficient. And in this case, b was 2. So b is 2. We're going to plug in half of that, which is positive 1. Positive 1. And now we're going to do the squaring part, the completing of the square. We're going to say x plus 1 quantity square equals, and this is 5 plus 1. We know this 1 squared is 1, so it equals 6. Okay, so we're left with this. Now we're going to move this guy to the other side and write back in function notation x plus 1 quantity square minus 6. Okay, so again, now it's in vertex form. It went from standard form to vertex form, and we're now ready to write our vertex. All right, so again, writing the vertex wasn't required here, but I'm just letting you know how we would find the vertex. Okay, so here it is. So the vertex, again, in this case, is that h comma k. It's always the opposite. So it's -1, and this one is always direct, so -6. So here we have two really good examples of a vertex form of a parabola, of a quadratic.